This is chapter 5, problem number 2. The lucky number for this problem is 4. So this is the lucky number for this problem, number 4. All right, so the question asked to determine the horizontal and vertical components of reaction at the pin A and the reaction on the beam at point C over here. All right, let's look at this one. Just go over a very quick review. So the magic formula for this one is moment, the sum of the moment at certain pivot, that is equal to x times the force in the y direction minus the y axis component times the force in the x direction. That will be our magic formula. All right, let's look at this one, 1.5, 1.5. So this is a isosceles triangle. This will be 45 degree, and over here is also 45. So over here it will be also 45. We are going to take a point as our pivot. So I'm going to say point A here is my pivot, for example. So what are the torques? What are the moments that is done on it? This one, the force, the 4 kilonewton acting on point B is going to make the beam go clockwise. So over here, the force must be going in this direction to make it go counterclockwise. This is a joint, so the force must be going at the same direction along the member over here. Let's look at it. So the moment is equal to that one. I'm going to write it equal to, there's a force over here. Let's say this force is X or force C. So it has two components. One component is force C in the X direction. That means it is equal to force C times cosine of 45. So that would be the force in the X direction going to the right. So it's positive. Also the Y direction is going up in the X direction. Force C times sine 45, that would be the force in the Y direction. Over here, X, 1.5 over here, times the force in the Y direction. So that is force C times sine of 45 minus Y is 0 times force X, so it doesn't matter. And then we add another moment to it that is done by the 4 kilonewton, so plus 4 kilonewton times the arm length over here, that is 1.5 plus 1.5, so that is 3. Okay, so because it's at equilibrium, so this will be equal to 0. The moment will be equal to 0. Okay, so in this case, let's look at it this way. This one is going clockwise, so the sign should be minus. So over here, instead of positive, it should be minus that number. So FC sine of 45, and that is times 0.707. That should be equal to 12 divided by 1.5, and F at point C over here should be, so 12 divided by 1.5 and then divided by 0.707, that is equal to 11.31. So the force acting from this member toward C is 11.31 kilonewton. All right. What happens if I decide not to pick point A as my pivot? If I pick the other one, if I pick point C as my pivot, what will happen? So let's look at it. If point C here is my pivot, so you have a force going down, you should have another force going down over here in order to balance it. Okay, so the one going clockwise should be equal to the one going counterclockwise, and therefore over here it must be 4 kilonewton in order to balance it if one C here is my pivot. Okay, so over here I have a force of going in the x direction. Before, what we calculated, it was the force is 11.3. So in the x direction, it will be 11.3 times sine of 45. So it will be about a kilonewton. That is in the x direction. Okay.